Hello, my name's Brian Huggett and I'd like to explain to you the operation of this sundial that I've made. I'm not intending to talk about the physics in any great detail. If you'd like to look into that further, I suggest you either go to my website where I describe the operation of this sundial, or alternatively to the website of the British Sundial Society, where there are excellent descriptions of how and why sundials work. The web addresses for both of those sites appear on the description of this YouTube video. This sundial is an equatorial heliochronometer. A heliochronometer is a sundial from which you can read the time that would be displayed on a properly adjusted clock. This one's accurate to about a minute. An equatorial sundial can be visualised as if it was a cutaway model of the Earth, with the plane of the dial plate here, where the timescale is positioned, being parallel to the plane of the Earth's equator. And the Gnomon, that's the element of the sundial that casts the shadow onto the timescale, with the Gnomon being parallel to the axis of the Earth. Now, in order to achieve those two things, the angle of the dial plate to the horizontal has to be set correctly, and the north-south orientation of the sundial also needs to be properly set. Equatorial heliochronometers can be designed with a fixed angle of the dial plate to the horizontal. That of course means that they can only be used at one specific latitude. This one is designed to be used at any latitude within the British Isles, and that change of angle is affected by this brass screw jack, which is designed for skylight windows. Now, as you'll see if you look at the diagrams on the British Sundial Society website, the angle of latitude is actually equivalent to the angle between the Gnomon here and the horizontal. And you can see that the latitude scale here isn't measuring that angle. It's measuring what's sometimes called the co-latitude, which is 90 degrees minus the latitude. And you'll see that to compensate for that, the latitude scale is actually calibrated for latitude, which is why the number increases as the angle decreases. Clearly the latitude scale would not be accurate if the base plate was not horizontal. That's checked using this spirit level. This spirit level is fixed to the base plate, and it was originally designed for use with a record player turntable. When the bubble is in the centre, then the base plate is horizontal. Corrections are made by 3 adjustable feet which are beneath the base plate. I mentioned earlier how an equatorial sundial could be considered as if it was a cutaway model of the Earth, with the plane of the dial plate parallel to the plane of the Earth's equator and the Gnomon parallel to the Earth's axis. A consequence of that is that it's orientated in relation to the Sun in exactly the same way the Earth is, and so shadows pass across it in the same way that they pass across the Earth. Now, a very helpful consequence of that is that the spaces between the graduations on the time scale are uniform. If the Earth spins round once, it's gone through 360 degrees, and there are 24 hours in a day, so if you divide 360 by 24 you get 15, and the angle of each hour between one hour line and the next is always 15 degrees. Now that makes it very helpful when you're attempting to compensate for the equation of time, compensate for longitude, or compensate for daylight saving time, because it simply requires a mechanism that rotates the dial plate and the time scale to make those relevant corrections. Now, the first one I'd like to talk about is the equation of time, and the scales to correct for that are here. One is on the moving section of the time scale here, and the other one is on the fixed section of the dial plate. As I mentioned earlier, this sundial is a heliochronometer. which means that the time read from it should match that on a properly adjusted clock. I mentioned that some corrections were needed in order to achieve that, and one of those was the equation of time. But what is the equation of time? The Earth's orbit around the Sun is not perfectly circular, and the axis of the Earth is tilted in relation to the plane of its orbit. This means that the duration of a day, as measured by the time between one solar noon and the next, differs throughout the year. This difference between a solar day and a 24-hour day throughout the year is described by the equation of time. Now, because the graduations on the time scale of an equatorial sundial are uniform, to correct for the equation of time in any day simply requires a mechanism to rotate the time scale arc by the correct angle to compensate for the equation of time correction for the day. The angular rotation of the time scale arc to correct for the equation of time on this sundial is achieved by aligning two lines, one on the inner moving section of the sundial and the other on the static outer section. For example, if I align the two lines there for the 25th of March, the correction of time has been made for the 25th of March. If I come over here and align those two lines for the 1st of January, then the equation of time has been built into the orientation of the time scale for the 1st of January. Now, you may notice that the important thing is where the line on the inner scale is in relation to the related line on the outer scale. It's the angle between the two that causes the correction for the equation of time. It doesn't matter where any particular pair of lines is positioned in relation to any other pair of lines. And that's allowed me to be able to place all the British summertime dates on one side of the dial and all the Greenwich Mean Time dates on the other side of the dial. Clearly there is a 15-degree offset between those dates and those dates to take into account the hour difference between BST and GMT, and also clearly there is some duplication of dates on either side because some dates fall within British summertime or fall within Greenwich Mean Time depending on the year. The equation of time correction is needed daily, and it's quite a fine correction, as you can see, which is why there's a mechanism built into this sundial whereby this knob connects to a pulley and belt system underneath the sundial to allow very fine adjustment of the equation of time correction scale, and very easy adjustment every day. Here is a slightly more close-up shot, and I'll align the equation of time correction scale for the 25th of March, and now as a second example I'll align the equation of time correction scale for the 1st of June. In order to read clock time, the sundial has to be corrected for longitude. This garden is located about 1 degree west of Greenwich, which means that when it's solar noon in this garden, it's around 4 minutes past solar noon at Greenwich. So in order for this to read Greenwich Mean Time, or British Summer Time, which is Greenwich Mean Time plus an hour, it has to be possible to rotate the time scale arc and leave it at a permanent setting such that the time here reads around 4 minutes later than the time that it would read if you simply looked at the position of the sun. And that is catered for by having the outer equation of time scale, which I've already described, being movable. It's connected to the base by wing nuts underneath. It's quite easy to move, but on the other hand, as with the latitude correction, it's specific to this location, so one only needs to correct for latitude or longitude when one physically moves the sundial to another location. But when the wing nuts are undone, it's possible to move the outer equation of time scale by an angle that can compensate for longitude. And here's a scale down here where the specific longitude can be set. This is a more close-up view of the longitude scale. You can see that the outer equation of time scale can be rotated, which in effect moves the final location of the time scale to compensate for longitude, west of Greenwich or east of Greenwich. This scale can then be anchored by wing nuts, which are located underneath the dial plate. This is simply a view beneath the dial plate that shows the belt and pulley mechanism that moves the time scale arc, and the one of the wing nuts that holds the outer equation of time scale in place. You can also see the adjustable feet that are used to level the base plate. One critical adjustment that I've not just mentioned is how one gets the sundial onto a north-south alignment. Clearly the longitudinal axis of the sundial has to run north-south, with south in that direction and north behind me. Modern clocks are so accurate that if one makes all the corrections that I've already talked about and then orientates the sundial such that it's reading the right time, it will automatically, if everything is correctly adjusted, be on a north-south alignment. Consequently, there is no other mechanism built into the sundial to produce a north-south alignment. You may have noticed that the Gnomon supports are based on the principle of microphone booms. The Gnomon itself is a piece of Kevlar string as used for stunt kites. The advantage of that is that it can be kept perfectly straight because it's tension between its support points. But it is held there in a way that makes it difficult to maintain its exact alignment. The alignment is achieved with this Gnomon alignment tool, which screws onto mounts which are fitted into the top of the dial plate. When they are screwed down in position and when the block here is aligned with the front of the time scale, then the Gnomon adjustment tool is in the correct location. This is the front of the Gnomon alignment tool. When the Gnomon string is just touching the surface here and is in alignment with this line, then the Gnomon is in the correct position. You might notice this bead on the Gnomon string here. That's called a nodus, and that relates to the date scale, which I'll be explaining shortly. There is a notch in the Gnomon alignment tool for the nodus to fit into. That allows the string obviously to lay flat against the front of the tool, but it also is in the correct position to locate the nodus where it should be to cast a shadow for a correct date. The Earth is tilted on its axis in relation to the plane of its orbit. Because of that, the Sun appears high in the sky in summer and low in the sky in winter. If you imagine my fist being the Sun in summertime, it would cause this nodus to cast a shadow low on this scale. In winter, when the Sun's down here, it would cause a nodus to cast a shadow higher up on the scale. That's the basis of the date scale. Because the angle that the Sun appears to be in the sky is predictable, it's the angle from the equatorial plane is sometimes called the declination. It's possible to have a mark on a scale like this to represent each day of the year. I've made this scale movable because had it been one large scale, it would have been quite difficult to read. From June to December, the Sun starts high in the sky and comes down to its lowest position. From December to June, it goes up the other way again. So each date sort of overlaps with another date each year, and it could make the whole thing rather complicated to read. Whereas with this moving scale, you can simply line up with where you know the appropriate date is. I put the December to June dates on one side and the June to December dates on the other. Here is a view of the time scale that incorporates the final ingredient to make sundials work, namely sunshine. You could see that the shadow on the time scale is at around 11:35 in the morning, which is correct. Here is a view of the date scale with the shadow of the nodus visible. As you see, you can move the scale around to track the Sun. And today is the 19th of October. If you would like to know more about the design and construction of this sundial, then please visit the website I've made about it. The details of that are in the description of this video. That website also contains dimensioned photographs, and it contains the files which you can download for free of all the graphics that appear on the scales of this sundial. If you want to know more about sundials in general, then I would definitely recommend the website of the British Sundial Society. Well, all we need now is for the sun to keep shining. Thank you for listening.